Hi, welcome back for the video presentation on Chapter 2, Lesson 1. We had already looked at what atoms are, and we also looked at what elements are, and we saw the difference between the two. When you look at what we are having here, for example, we have here carbon. Carbon is one of the elements that we know. Carbon is an element, and normally when we have many of them together, they form something like, for example, as we see here, this carbon comes from nothing, but it comes from charcoal. So the charcoal that we know is carbon, and the gold ring is also another example of an element. So if we are looking at gold also is one example of an element. So we have aluminium, we have aluminium element. We are having also charcoal here, which makes the carbon. Then we have gold. So we have carbon, we have gold, we have aluminium, and so forth. So all these are elements. We said that out of the around 91 elements which occur naturally, elements that occur naturally, only about 25 of them are known to exist in living organisms. So only are found in organisms. We looked at examples being, for example, carbon, hydrogen. We looked at carbon, hydrogen, nitrogen being the most abundant, and oxygen. But still, we have other compounds which are also very important when it comes to we have other compounds which are important when it comes to, for example, we have calcium. We have calcium, which we know as very important. We have magnesium. We have iron, which is important in capturing of oxygen or getting of oxygen by the hemoglobin, and so forth. In the next unit, the next thing that we will look at is what we call compounds. So when we are looking at compounds, then compounds are basically atoms of elements found in, compounds are substances made of atoms of different elements. So what we will call, for example, compound. So a compound is a substance is a substance. A compound is a substance made of atoms, made of atoms of different elements, of different elements bonded together. So as we discuss, we will look at how these bondings occur. For example, you can see here that we are having 2 hydrogen atoms coming together with 1 oxygen atom to form a water molecule. The foods that we eat are compounds. The water that we drink is a compound. So we might have compounds of different types, like here as you see, we can have like compounds of different types. We can have water, which is made of hydrogen, carbon, and oxygen. We might have 2 hydrogen atoms coming together to form hydrogen molecule, or 2 oxygen atoms coming together to form an oxygen molecule, and even 2 hydrogen atoms and 1 oxygen atoms forming a water molecule. So this means that molecules are varied. Some of them are even made of a big number of elements. Like, for example, let's take an example of vinegar. So if you see here, you will discover that we have hydrogen, carbon, oxygen, hydrogen. So we have how many carbons? 2 carbons. How many hydrogens? 3 hydrogens and 2 oxygen coming together to form this compound we are calling vinegar. So all matter that we come across, is be it in form of a gas, or be it in form of a liquid, or even a solid, they are all made of matter. So part of a molecule of plastic, for example, is just a chain of carbons. And so forth. So these molecules of air also will have oxygen molecules. Normally oxygen is a diatomic molecule. It exists in 2. We might have nitrogen, oxygen. These are diatomic molecules. We have others which are varied. These are atoms. These are molecules. These are atoms. These are molecules. As you see here, molecules are made of 2 or more elements, while atoms are just made of single element, argon, neon, and so forth. Nitrogen, here elements. These, even though they are elements, they can still make compounds. So compounds can be made of either elements of the same kind or elements of different kinds and so forth. So, as we discussed earlier, it is clear that all matter is made of particles called atoms. All matter is made of particles called atoms. An element has only one type of atoms. Each element has its own name and symbol. Each element has its own name and symbol. Atoms can join together to form molecules. Atoms can join together to form molecules. Atoms can join together to form molecules. Elements can combine in chemical reaction and form compounds. Each compound has a name and a chemical formula. Each compound has a name and a chemical formula. So for better understanding, we use scientific models. For better understanding, we use scientific models. Here we have hydrogen atom, and here we have oxygen atom. Hydrogen atom, for example, has 1 proton and 0 neutrons in its nucleus. The outermost shell or energy level here has only 1 electron. It has only 1 electron. If we look at oxygen, we will see that an oxygen atom has 8 protons, it has 8 neutrons, and the innermost energy level, which is this first ring, is having 2 electrons in the innermost energy level, and here in its outer energy level it has 6 electrons in the outermost energy. So the model of atom developed by Niels Bohr, was developed by Niels Bohr, shows that an atom electrons are located outside the nucleus in the regions called energy levels. Different types of atoms have different numbers of electrons and energy levels. So often atoms are shown as simplified spheres, as you can see them in the diagram here. So if we are having compounds, if we have so what you see here are chemical compounds. This is a compound of water, which is made of oxygen, and not only is it made of oxygen, so if we have this as oxygen, and then it is an atom coming together with another atom, which is in this case hydrogen. So they come together in a specific ratio, then they form what we call a compound. They form what we call a compound. They form what we are calling a compound. Here we have 2 hydrogen atoms with 1 oxygen atoms making H2O, what we call water. What we call water. The next thing that we are going to look at are ions. The next thing that we are going to look at are ions. So here we can say that normally compounds' properties are often different from the properties of the elements that make up the compound. So what is unique about compounds is that the elements, so a compound a compound. A compound's properties are often different from the properties of the elements, properties of the elements that form them, of the elements that make up the compound. We will take a simple example. We know that oxygen is a gas, and we know that hydrogen is also a gas. So when this one molecule of this oxygen and one molecule of hydrogen, two molecules of hydrogen come together, what do they form? They will form what we have seen as a compound, and in this case they will form H2O, sorry for this. So they will form H2O. So here we have the oxygen. So together H2O will have different properties completely from what made them. In some cases, it's even weird that some of the elements that form compounds which are foods might be poisons themselves. Like, for example, if we take chlorine gas is a poisonous gas. But when chlorine is together with sodium, which is a solid, it forms sodium chloride solid, which is a table salt that we use in our food. A substance that is made of atoms of different elements and bound together, they are normally bound together in certain ratios. Like you can see here the ratio. So if we are looking at specific ratios, these compounds have specific ratios. Like here you can see that we have 2 hydrogen and 1 oxygen. So the ratio here is 1:2 in terms of 1 oxygen and having 2 hydrogen. Next is ions form when atoms gain or lose electrons. Ions form when atoms gain or lose electrons. So an ion is an atom that has gained or lost 1 or more electrons. So an ion is an atom that has gained or lost 1 or more electrons. 1 or more electrons. An ion forms because an atom is more stable. So an ion forms because an atom is more stable when its outermost energy level is full. When its outermost energy level is full. So when its outermost energy level is full, then it becomes stable. Otherwise, it remains unstable, and it will either lose or gain electrons depending on the number of electrons it has in its outermost energy level. So the gain or loss of electrons results in a full outermost energy level. Let's look at the example here. We have sodium atom. We are having sodium atom, and we are having a chloride atom and a sodium atom. So this is a metal, this one is a gas. So here 1, 2, 3, 4, 5, 6, 7. This one has 7 electrons in its outermost shell. So it has 7 electrons. How many does sodium have? So sodium has 1. Sodium has 1. So this is number 17, and sodium is number sodium 11. So this one here will lose this 1 electron. It will lose this 1 electron, and because it loses that 1 electron, it will become positively charged. It will become positively charged. And this one, because it receives or gains 1 electron, it will become negatively charged, because we know electrons have a negative charge. So if you receive an electron, you become electronegative, and when you lose it, you become electropositive. So the positive sodium ion and the negative chloride ion attract each other and form what we are calling ionic bond. So an ionic bond is formed by attraction. It's formed due to an attraction between the two molecules, between the two elements. So we can see here that what happens is so what happens here, as we can see, is that we have sodium and we have chloride ion. So sodium and chloride, we have electrons, protons, and charge. So here we have 11 and 11, and we have 0 charge. This means it will be stable if it has 11. This one also 17, 17. So they are neutral, but when they come together, this one will lose the outermost electron, and this one tends to pull this electron towards itself. As it does so, what happens? As this happens, you can see this one will have more electrons more positive than the negatives. So it becomes more positive, and this one, because it will have more negative, it will become negatively charged. This one will become negatively charged. This one becomes positively charged. This one becomes negatively charged. So electrons and protons charge positive. We can look at another set here. We are having carbon. We are having carbon at the ratio of 2 to 4, at the ratio of 2 to 4 or 2 to 8. So carbide ion. So carbide ion has a -4, which means it receives 4 electrons. It receives 4 electrons. So when it receives 4 electrons, it becomes charged, and the one which lost 4 will become positively charged, carbon ion. So we have here carbon ion as just an example, as just an example. That is it with the forming ionic bonds. So basically, we will go through again to in a summarized form. So we have said that some ions are normally positively charged. Some ions are positively charged, which means they they lose an electron. They lose an electron. They will lose, and so the atom which lost electron will form a positively charged atom losing an electron. So the atom which lost the electron will form a positively charged ion, and some ions are negatively charged. Some ions are negatively charged. Some ions are negatively charged. So the types of ions that form depends on the number of electrons in an atom outer energy level. So if it has, for example, less electrons in the outermost shell or outermost level, then these electrons are easier lost. But if it has more electrons, it will have the tendency to attract other electrons towards itself, and in this case it will gain the electrons instead of losing it. So an ionic bond forms through the electric forces. So what we are calling ionic bond, it forms through electric forces. Ionic bond forms, an ionic bond forms through the electrical forces, the attraction of the electrical forces. The attraction of the electrical forces. So we have already looked at the examples here. In the next video, we will look at covalent bonds and how they are formed.